Hey everybody, Mr. Covey here, and so in this next chapter we are going to be studying polynomials. We will talk in class on the block day about what our definition of a polynomial is, but before we do that I wanted to get down some vocab, okay, that we can use to talk about graphs of polynomials. Okay, so I'm going to write down some definitions here at the bottom, and then I'm going to do the example above, because the above would be an example of a graph of a polynomial. Okay, so first couple things here, and I might do these out of order. You can talk about when the graph is increasing or decreasing. Okay, so like you might guess, increasing means going up. When is your graph going up? Decreasing means going down. There's a couple of other ways to think about this that might be helpful. Instead of thinking about it as going up, you can think about it as having a positive slope. So it is sloping upwards when it is increasing. And instead of thinking about it as decreasing as going down, you can think about it as having a negative slope. And then perhaps the most important thing when thinking about increasing, decreasing is you always think about the graph moving from left to right. Why from left to right? Someone just decided that. It's kind of like, why do you read from left to right in English? Because someone decided that. So we're always going to look at the graphs from left to right and ask, is it going up, positive slope, or going down, negative slope? Constant then just means, well, it's not going up or down. It's flat, it's horizontal. And it would have zero slope, or a slope of 0. Okay? So if we come up here, and let's just start by identifying where the graph is increasing. So I'm going to do increasing in green, decreasing in red. Moving left to right, this is definitely increasing. Then it's decreasing. Then it's increasing. Then it's decreasing. And the last part's increasing again. Oops, sorry. There are no chunks of this graph that are horizontal, so there are no constant parts. Okay? Now the important part is, how do you describe these different chunks, these different sections of the graph? We are going to describe them with intervals of x values. Okay, so where is this graph increasing? Well, if you look at that green chunk there, that green part on the left, it's going all the way to the left. So if I was going to describe the x values, going all the way back to negative infinity, this graph is increasing. It's increasing, 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 stops increasing here. I'm going to look at the x value, and I'm going to say it stops increasing at an x value of negative 3. Okay. Next, I want to also say there's another part where it's increasing, this part here. Again, I'm going to look at the x values from x is negative 1 to x is 2. I'm going to write that like this, negative 1 comma 2 with some parentheses. And the last part, an x value of 4 all the way to the right to an x value of infinity. Okay. Decreasing similarly, from x equals negative 3 to x equals negative 1, it is decreasing. So from negative 3 to negative 1, between those x values, it's decreasing. And it's also decreasing between an x value of 2 and 4. So those are two separate intervals where the graph is decreasing. Notice that there's 3 parts where it's increasing, so we had 3 intervals there. 2 parts where it's decreasing, so we had 2 intervals there. Constant? None. This graph is not flat anywhere. Okay. 2 other terms. And again, maybe we should write down here that when we're talking about increasing, decreasing, constant, we're looking left to right, and we're also looking at x value intervals. Important that we think about the x values. Okay. Maximum and minimum points. We're going to think about these, what I like to call relatively. That's the term for it. I don't make it up. So we're going to look at relative maximum and relative minimum, which means it doesn't have to be the top point overall to be a maximum. It doesn't have to be the lowest point overall to be a minimum. Instead, we kind of just think about a relative maximum as being on the top of a hill. It might not be the tallest hill in the whole graph, but as long as you're on the top of the hill, we're counting that as a maximum. As long as you're at the bottom of a valley, you're at a minimum. Okay? So maximum, kind of like we did with parabolas. Here's a maximum. Here's a minimum. Okay? And both of these are points. Just like when we talked about it with parabolas, maximum, minimum is a point. Okay? So here, we actually have two maximums. This is the top of a hill. This is the top of a hill. Both of those count as maximums. Okay, so we'll list those 2 points out. Those are maximums. No, they're not the highest the graph goes. Oops, I should rewrite that. The graph goes higher over here. It goes up to, keeps going up here. But they're tops of hills around them, so we call them relative maximums. So we are counting those as maximums. Minimums, we have 2. That's a minimum, and that's a minimum. So -1, -3, and 4, -1. Okay. Last piece of vocab is end behavior. And this is what happens to the graph as you go off to the left and as you go off to the right. Does it go up or down? Okay, so here's the fancy notation we're going to use to describe that. If I'm asking you as the graph goes off to the left, I'm going to say as the x values go to -infinity. In other words, as I go off the graph to the left. What happens to my y values? Do my y values go up or down? So there's 2 options. If it goes up as I go off to the left, then I say positive infinity, be up. If it goes down, I say negative infinity. So your end behavior is always going to say is x goes to negative infinity, y goes to, and it's either going to be up or down. The other thing you have to describe is what happens as x goes to the right, and that's when x goes to infinity. Okay, so as x goes to the right, what happens to y? And again, you have these same 2 choices here as above. Either it goes to positive infinity because it goes up, or it goes to negative infinity because it goes down. So you're saying as you go to the right, do you go up? As you go to the left, do you go up? Or do you go down for both of those? Okay, so for this graph here, as I go to negative infinity for my x's, as I go to the left, graph goes down. So my y's go to negative infinity. As I go to the right, as my x's go to infinity, well, if I follow this graph to the right, it goes up at the end. So my y's go to infinity. Okay? So those are the core vocab concepts we're going to be focusing on that are going to help us describe these more complicated graphs we're looking at here. Okay, so if you could flip over to the next page, please. Before we start, if you could put some little arrows on here, because this graph does go on forever. And I'd like you to pause the video now and try and fill in this information for this graph. Then unpause it, and I'll show you the answers in a few seconds here. So go ahead and pause and try that on your own. Okay, so over here are the answers you should have gotten. We have 2 intervals where it's increasing, -5 to -3. And I estimated this at around 0.5. So I said from x is 0.5 to x is 2, it's also increasing. Just an estimate. Decreasing? Well, -infinity all the way up to -5. -3 to that 0.5, and then also from 2 to infinity. So there's 3 red regions where it's decreasing. 2 maximums, 2 tops of hills, right there and there. 1 bottom of a valley, 1 minimum, oh, excuse me, 2 minimums. Right there is the bottom of a valley, right there is the bottom of a valley. Again, those are points. So this says, oops, yeah, 0.5, I know it's kind of hard to read, sorry. That says 0.5, -100. Okay. And for end behavior, as x goes to infinity, so that's as I go to the right, I go down. My y goes to -infinity. This statement says as I go to the left, my y goes to infinity. I go up. Okay. We will practice this in class on the block day. One other thing I wanted to touch on was how to do this on your graphing calculator. But I think that'd probably be better just to do on the block day together. So if you could make sure that you bring a graphing calculator. So now we're going to be using our graphing calculator all the time. Bring a graphing calculator to class on the block day. We're going to talk about actually graphing these on your graphing calculator and then identifying these different features here. Cool? That concludes this video. Thanks, guys.